So this is some explanation videos for the astrophysics unit. For the first section, the E1 section, there's a lot of basic information that you've got to know. I'm not going to talk about it too much. I have sort of outlined here things that you need to know. So you need to look at that carefully. You have to be able to define certain things like the light year, and certainly know how to use that. We've got comparative distances and so forth. So it's going to be important to use your textbook. You've got two textbooks, and they've got a lot of information in them. So for the first section here, we have defining the light year, for instance. This is over here. I'll talk about this now. Light travels at 3 times 10 to the 8 meters per second, and it's the distance that this light will travel in 1 year. You need to be able to calculate the number of seconds in a year, equals roughly something like that. This value is actually the distance in meters is actually given in your data booklet. Notice the point over here, the separation of galaxies in a cluster is in the order of 10 to the 23, and the separation of galaxies in the order of 10 to the 24. And makes this point over here that one increase in the power of 10 does not sound a lot, but these values, it is a huge amount. So times 10 of the distance between galaxies in a cluster is a huge amount. You also need to have an idea of the night sky, how that works. So why the night sky changes during the day, during the night, and also during the year. And so you need to read up on that carefully. This whole idea of a constellation is important. What is a constellation? This is something in ancient times, people would make constellations, and this is a recognizable group as viewed from the Earth. They may not be close in actual fact, but in a galaxy, or stars within a galaxy, or in a group, a stellar cluster, these are stars that are held together by gravitational attraction. There's one thing I want to spend a little bit of time with, and you can, I'll just call up this document over here. In the Sun, energy is gained in the Sun through nuclear fusion, and I've just written out the formulas roughly here. So we start off with regular hydrogen, and it fuses with another hydrogen. This is your normal isotope of hydrogen, and it forms something called deuterium, and in the process it gives off a positron, a beta plus, and a neutrino, and gamma radiation. Now this deuterium hydrogen isotope fuses nuclear fusion with a further regular hydrogen 1 isotope, and forms your helium-3 isotope, and then 2 helium-3 isotopes fuse together to form the helium-4 isotope, and it gives off 2 regular hydrogen again. So this is the process, quite a complicated process that's taking place. But in each case, as we go from there to there, and from there to there, energy is being released in those fusion reactions. So this is the energy that the Sun gets. It comes from this fusion process. So going back to our notes over here, I think it covers most of it. I've discussed a little bit on this point over here. State that the fusion is in the main energy source of stars, and we are just interested in here hydrogen is converted to helium, so we saw that over there. So that's the energy that our sun is producing for us at this time. Alright, so I'm going to leave it there, and then in the next video I will continue on further under E2. Thank you very much.